Good morning, everyone. Thank you for joining us today. We have an excellent webinar. I'm personally very excited about this one. The topic, as you know, is connected autonomous vehicle side, and Peter Ashley will be looking at TravelSafely. And this is a very neat app that really brings kind of connectivity that many people still talk about it in research circles, right? But this is something that's already out there today. So we're very excited for Peter to having joined us. But before I hand it over to him, I just have a few slides to share with you on how Ontario Good Roads Association is playing a role in the connected and autonomous vehicle space. So as some of you may know, 1894 was the year when OGRA was born. And this was the time when there was a transition from horses to horseless carriages or cars. And now, if you fast forward to today, then we're seeing a similar transition happen, but this one is happening within the vehicle itself. So this one is going from manual to truly automatic. And in many ways, we feel that the transition from horses to cars was big enough. But if you look at the transition that this new era is expected to bring along, it will likely dwarf the impacts that we saw in the last century, which were huge in themselves. All in all, we do feel that it is in OGRA's DNA to be involved in this spectrum and specifically to try to support our municipalities, just like we did in the earlier transition. And we want to be at the table and we want to start the discussions early so that we can all work together. Another parallel is that February 9th, 1894 was when the first OGRA conference took place, which was very small compared to the conferences that we have today. But still, it was a milestone. And we feel a similar milestone started on March 26th of this year, which was when we called a number of key municipalities to discuss the idea of the connected and autonomous vehicles and the role that the municipalities will likely have to play going forward. In particular, we talked about the Windsor-Ottawa vision of OGRA, and this simply builds on top of the AV pilot regulation that has already been in place for a couple of years, but we're looking at it from the municipal angle. In a nutshell, the idea is that every participating municipality, so this is not a mandatory exercise, anybody who wants to participate, what they are being asked to do by OGRA is to identify their local preferred routes. And when they do that, they all submit those routes back to OGRA. And then what we will do is that we will work towards creating a seamless corridor from one end of the province to the other. One of the key groups of OGRA that's working to enable this Windsor-Ottawa vision is the MACAVO group. This is the Municipal Alliance for Connected and Autonomous Vehicles in Ontario. We started with a small group very intentionally. We just wanted to understand what the role of municipalities should be. And as of last 3-4 weeks ago, we sent an invite to all municipalities in the province and giving them the opportunity to be a part of this. So very likely, most of your councils would have received a letter from us now, and we are receiving a lot of positive feedback and support. We understand that the autonomous vehicles and the connected vehicle space is very much a test phase right now. So that's why it's kind of important to create these preferred routes so that we can all channel in our resources and logistics together on specific places rather than all the roads. It just makes it for that much of an efficient deployment, we feel. And one of the big reasons also that we are taking part in this connected autonomous vehicle space is because if you look at the road-related fatalities that happen each year, there's 1.25 million fatalities that happen across the globe. If you may know, your plane's A320 has 180 passengers each. So 6,900 A320 planes vanishing every year. Not a good thing. And out of those 6,900, 11 of those crashes are happening on Canadian roads. That's over 2,000 Canadians dying each year. And if you look at the US, the numbers are much higher. So it's over about 119 planes. All in all, the idea is that there's a lot of fatalities that need not happen. And we should not have to wait for years and years of research and development before some of the good technologies can be deployed today. And for that reason, for the MACAVO group, our intentions will be to try to help work with the industry directly and support their good work and try to bring the level of fatalities down as quickly as we can. So with that, the TravelSafely app is something that we came across not too long ago, and we were just blown away by the things that it does. And I don't want to take any more stage time, so what I will do is I'll pass it on to Peter.
Perfect. Thanks, Fayed. Thank you, everybody, for attending I'm going to try to keep this as interactive as I possibly can. I've got some videos and a couple of slides to show, and I'm going to just give you guys a little bit of a background on who Applied Information is. We're based out of Atlanta, Georgia. We've got offices around the world, in India, South Africa. We've got offices in New York and Portland and Texas. And you know, the whole idea behind the company was to start something that made all of these technologies in the transportation sector all just work better. Currently, at the moment, we installed in over 400 cities. We've got about 7,000 devices deployed, and we're about 50 people, but majority of them are engineers. So, you know, we're very much of an engineering company. And the whole premise of it was, how do we make the technology that's in the transportation sector work like your smartphone and your iPad? You know, I've got a 85-year-old grandmother that can pick up an iPad and make a Skype call with me, which, you know, how do we make the same kind of technology and bring that over into the transportation sector? So there are a couple of key technologies that we use to do that. The first is cloud and web-based software to connect everything to everything. That allows us to have anyone can use any smartphone to access the system. There's no software required for any of the cities either, and all the updates just come automatically. All of the devices in the field have got built-in cell modems, built-in GPS, and they automatically communicate back. And one of the other things that we moved away from was everything works like your smartphone. You don't have to type in complex IP addresses and things like that. Everything's synchronized with the central. And probably the most key technology as a takeaway is over-the-air software updates. In much the same way that your smartphone updates all the time, all of the traffic equipment can now also update, because when you're talking about smart cities and connected vehicles, one thing we know is things are going to change. People are going to dream up new functionality, new features, and the way to improve your technology with the times is to buy hardware and software that allows you to update it automatically in the field, so that you can add all this new functionality to it. Now, our system is a twofold: connected vehicle and smart city. So our devices monitor all the traffic cabinets and school zones in terms of if there are any power failures or cabinets going to flash or your lamps fail. The whole idea behind this is to know what the problems are at your intersections before it happens, so that you can send out a technician with all the correct equipment. And having all that information at your fingertips is only as good as taking all that data and turning it into actionable information in terms of which equipment is broken, what is the average response times for your emergency vehicles, are your buses driving around in service on time, are there people speeding on your roadway? So all of those kind of automated reports are done. This gives you a quick idea of smart cities. In other words, the smart city side of it, in terms of connecting up all your traffic signals, connecting up all your driver feedback signs, school zones, dynamic message signs, emergency vehicles, so that you can bring all of the devices within your city on one platform that allows you to monitor and control all of it. Now, at the same time that all of them are being monitored and controlled by the GLAN central system, they're also broadcasting all of the connected vehicle messages. Before I jump into explaining how the connected vehicle messages work, what I was going to do is just actually open up some short films that give you a good idea of how this works. Now, this is the TravelSafely system running in one of the new ones. We did a smart corridor in city of Richmond, and I'm just actually going to play through this and probably pause as I'm playing through it just to explain some of the concepts.
Get ready for green.
So this was done on about 10 intersections down a corridor over here. And as the vehicle approaches the traffic signal, that TravelSafely smartphone app automatically connects to the traffic signals and provides countdowns of when the traffic signal is going to change. But the whole idea behind this is people don't have to use the smartphone app in the car. They can be running any app. So all of our alerts are audible. So you're going to hear the get ready for green, which pops up an audible alert that the traffic light's about to change before the actual light changes, so that people can put down their phones and actually be connected to the traffic signals.
Get ready for green.
And the light goes green. And you can see how instantaneous the communications are as well. Similar kind of application here, as the person's approaching the signal, doesn't see it.
Red light.
The whole idea is we're tracking the vehicle's speed and determining whether or not he's going to slow down in time for that red light ahead. It's just adding layers of safety onto your traffic system. And same over here with
Get ready for green.
Get ready for green, and you'll see how instantaneous the communication is. It's telling you the left turn's active and the straight's active. And if you saw over there, it actually shows you exactly the amount of time, because we now know exactly whenever any traffic signal is going to change. So it's going to be at least 30 seconds before the traffic signal is going to go green. So what you find with this is when you drive through a city that's got it fully deployed and you're driving down there, your frustration levels are much, much less on the roadway, because people are always frustrated, when is this traffic signal going to change? And now, with the get ready for green messages, people aren't as worried anymore that they're going to, they're watching the traffic signal sort of all the time. And what it is the first time traffic signals have fundamentally changed in 100 years. That now traffic signals are talking to you as well as your eyes seeing what they're doing. And it's a fundamental shift. All you got to do is drive in one of these cities that has it deployed, and you get the idea about it instantly, because it feels so natural as well. So this is a school zone safety alert coming through as you're driving through an active school zone. And when you're driving more than 5 miles above the speed limit, the application's going to bark at you.
Speeding in school zone.
Telling you that you're speeding in a school zone. And if you have a look here, you'll actually see the vehicle speed, and you'll see when the alert actually pops up on the phone. As soon as we go, you see the speed limit is 25 miles an hour. As soon as we go above 30 miles an hour, you'll see the app actually pushing out an alarm.
Speeding in school zone.
And the whole idea behind this is adding layers of safety. Because you can basically have all these audible alerts now that provide you with alerts of when something's going to happen when you're speeding in a zone that's not that's not safe as well. So slowing people down in school zones is pretty important. There are a number of applications. Connected vehicle preemption as well is also a key. Connected vehicle technology that connects the emergency vehicles to the traffic signals. And how do you get the emergency vehicles to the scene quicker so that they can save more accidents and heart attack victims, is providing them with a clear path to the traffic signals. So the vehicle is actually communicating directly to the traffic signals and requesting a green light in this case. And what it does, it brings all of the other approaching phases to a stop. So you'll see the green arrows active and the green straight, so that everything else is brought to a stop, and that the emergency vehicle has a green wave going directly ahead. You can see there the vehicles at that next intersection are already stopped, so that he now knows that everybody else is brought to a safe stop, so that it's safe for him to go across that signal. And what's great with this is, because we use cellular and radio communication, we can communicate to traffic signals around the corners and over the hills as well. So that's around buildings and around, you know, geographical corners, so that you can bring everybody else to a safe stop. Now, the next thing you're going to see is the smartphone app getting the signal from the emergency vehicle approaching.
Emergency vehicle approaching from behind.
So one of the things that's happened is all of the cars are so well insulated today that you don't know where these emergency vehicles are coming from. You know, you hear the sirens, but you just don't know in which direction this emergency vehicle is coming from. So what we do is we provide an alert within your vehicle that there's an emergency vehicle approaching from behind, or approaching from the right, the left, the front, so that each individual vehicle knows what to do and where the vehicles are coming from, so they can act before the emergency vehicle comes. This is the same school zone alert that I was showing in the previous video. When the school zones are active, only when they're active do we provide these alerts. So it actually tells you the speed limit here is 25 miles an hour.
Speeding in school zone.
And it tells you what school zone you're actually in as well. So actually over here it says Westside Elementary and the school speed limit. And if you drive too fast again,
in school zone.
So the whole idea is you only provide alerts when someone's driving more than 5 miles above the speed limit. This is for driver feedback signs, which is another connected vehicle technology. Is people often put up these driver feedback signs in areas where you've got neighborhoods and sort of roads coming into a faster road, and you're trying to slow the people down in this area, but it's only in one point. So what we do is we extend the zone in the app to, you know, obviously in discussions with the city, in terms of where that zone should be. So as the person's driving through, you'll see that we'll get into this area, and there's actually a bunch of roads over here that are coming in. And as we go down the hill, this is actually the most unsafe area because people end up speeding up, and there are these ramps here.
Speeding in slow speed zone.
And when I'm driving more than 5 miles above the speed limit, it provides the alert. So we only provide alerts when people are driving more than 5 miles or 7 kilometers over the speed limit. This is the connected vehicle work zone alert. So when you have an active work zone where you have, you know, an arrow board, you know, changing, you know, reducing the lanes, changing the speed limit, we also broadcast that information to the drivers. So as the driver's approaching, he's actually going to now see that the speed limit is 40 miles an hour, because a lot of the times people don't actually see the speed limits. And it provides you that warning before everybody starts coming to you know, getting really closed off in terms of the speed getting reduced because of the work zone ahead. And so it's just another one of those safety things. A huge other aspect behind the TravelSafely app is what we're doing is we're not only connecting to the infrastructure, as you saw, we were connecting to the emergency vehicles, to the other apps, but we also connect to cyclists and pedestrians. One of the biggest increases in roadway deaths in this last year were pedestrians and cyclists. You know, there are more people on bicycles, there are more pedestrians out there, and there's more distracted drivers. And so what we've done is we actually connect on the TravelSafely app. It automatically connects you as a cyclist, pedestrian, or motorist, depending on your speed and travel, so that you can get these alerts that are going to come out and provide an alert that there's a potential for collision with a cyclist. So it pops up that there's a cyclist ahead and provides that audible warning. And it's popping up there that there's a high-speed vehicle approaching. Now I specifically rode in the road there, and obviously the cars are supposed to move away. We're just showcasing the technology here, that it actually will provide you the alert when you're in the lane of the vehicle traveling towards you. Now this was in Marietta, and they've got all of their 140 traffic signals connected, and obviously now the traffic signals are talking to the smartphone in the same way I showed you the previous application. This was shot a year and a bit ago, and you'll see what's also important is the TravelSafely app works in the background, so you can be running Waze on your phone, and the TravelSafely app is just going to provide its audible alerts over the Waze app. So if I'm driving too fast to the signal,
red light alarm,
just providing you the red light ahead and the get ready for green.
Get ready for green.
And you'll see the traffic light will change to green. So everything's these audible alerts that really provides this additional layer of safety to the citizens, within the city. And, the one thing that you've got to think about is before autonomous vehicles can actually operate in your cities, you have to connect all of your infrastructure, because an autonomous vehicle doesn't know it's driving in a school zone that's active. It doesn't know that there's a school bus. One of the biggest things that the autonomous vehicles are struggling with at the moment is, what do you do when an emergency vehicle comes? Because it can't hear. So, having the information of where the emergency vehicles are coming from is quite a critical thing. One of the other things that's interesting is, as a company, we purchased a couple of Teslas to experience sort of what is the current technology in autonomous vehicles and how does it work. And what they do very well is they create a bubble around the vehicle. They've got 12 ultrasonic sensors, 8 cameras looking around the vehicle, and forward-facing radar. And it builds this great bubble around the car that knows where all the other cars are within its vicinity. Now, this software isn't perfect. It's only really designed for highways at the moment, but it's improving at a rapid rate. The cars can now drive on arterials pretty well. They don't see traffic signals yet, but they're working on that. One of the things that they don't do very well is they're not able to anticipate what the traffic signal is going to do. Obviously, this kind of technology is feeding the information to them now, but also they don't react very well in work zones. They don't work very well when there's congestion at a signal and it's coming up to a signal that's already got congestion at it. So connecting all of this infrastructure up is a major benefit for for these autonomous vehicles that are coming. But even over and above the autonomous vehicles, having the TravelSafely app can provide real safety and start saving lives today, because there's, in the US, I know the statistics for that, there are 300 million smartphones in vehicles today. So, you can get a real quick implementation and offer up, as a city, for instance, Marietta and City of Atlanta, they call it the Marietta TravelSafely app, and they promote it to their citizens as a service where it is a free smartphone app, doesn't cost the citizens anything. And it ends up for them being a very beneficial thing, because they now getting ready for these autonomous vehicles, but they providing an impact today for the citizens by providing these red light alarms, people speeding in school zones, So it's providing real safety today. On the traffic signals, basically we're doing 4 different applications on the connected vehicle side. The countdowns that you saw, the get ready for green, then the traffic signal is also getting information from every single vehicle approaching. So what that means is every vehicle is now a detector. So now you actually have advanced detection on every single approach that's feeding detector input information directly to your traffic controller with all the smartphone apps. So that's how you can detect a cyclist coming towards your signal, is if he runs the app, it will put in a detector call 12 seconds before he comes to the signal. And you can prioritize your signals for cyclists if you want. The school zones, speeding in a school zone, TravelSafely apps in the vehicles, obviously providing alerts for cyclists and pedestrians. Emergency vehicles are getting the green lights at the signals, plus they're obviously broadcasting their messages to all the cyclists and pedestrians and motorists of where they're approaching so that people know that they're coming. There's the TravelSafely app that's telling you, more than 30 seconds before the left turn is going to go active, and currently the green is active right now. Red light alarms, speeding as well in sharp curves. So there's some areas of roadways where you've got a sharp curve that's mainly for highways. The school zone safety. Now, obviously, all of these devices, the intersections and the school zones, do more than just the connected vehicle side of it. They actually control when the beacons turn on and off. So it's remote scheduling of your school zones, where you can actually set it up that it will monitor your solar panels and your batteries, and you can set up all the schedules. But at the same time, we're making it future-proof, that it will actually send out what's called the signal phasing and timing information from these school zones that will tell you the area that is your school zone from the start of the school zone sign to the end of the school zone message over here, and it will alert you if you're ever driving too fast in a school zone. That's quite key. I find I drive around a lot of these different areas, and I don't, when I'm traveling around a new area, I don't know where the school zones are. And sometimes, you're a bit lost and you're trying to find out where you're going. You don't see the beacons. It's just adding this additional layer of safety, trying to basically slow down people in the school zones. Emergency vehicles, providing them with green lights and bringing everybody else to a safe stop using connected vehicle technology. Same thing with transit signal priority. So providing transit signal priority over, the radio and also cellular communication directly to the cabinets, so that you can give the transit vehicles also a green wave. And because you're using cellular communication to the traffic signals, you can keep all of your traffic signals in coordination, which doesn't provide a major impact on your traffic congestion, because you're sending it a full cycle in advance. We also are piloting truck priority using TravelSafely Pro. So some of the agencies are wanting to get the trucks off peak hour traffic and into non-peak hour traffic. And one of the incentives is if you use if you drive your trucks in off-peak, you're going to get a priority at the traffic signals so that you don't have to stop as often. And also, it's other ways of getting trucks off certain corridors and putting it onto another corridor where they get an incentive because they don't have to stop as much. Now, the cost of a truck stopping is about $2.60 per time that it stops. So there's a huge cost implication for the trucks and also for the cities, because each time a truck stops at a traffic signal, it compresses the roadway. It's a heavy vehicle, compresses the roadway, and that often causes, most of the potholes and the damages to your roadways is big trucks stopping at signals. So prioritizing them at certain signals provides a real benefit for getting them off the roadways during peak hour traffic and into off-peak, and also just saving the roadways. Where the emergency vehicles coming from, cyclist and pedestrian safety, which is a huge factor, and obviously the TravelSafely app. This is app-to-app communication, and it provides basically a 5-second alert in advance so that people can actually react to that. We also hook into pedestrian crosswalks, so rapid flashing beacons, hawk signals that will provide an alert to when someone pushes a button and activates the rapid flashing beacon that there's actually an active pedestrian crossing ahead. Speeding in work zones, this gives you a great alert that when you're actually speeding in a work zone. I wanted to go over just a little bit. This is, all the applications that happen behind the scenes. Basically, we're utilizing two boxes in the field that get this. There's a box that goes into a traffic signal cabinet. This is the front of the box, where you can see the different preempt outputs over here. And it obviously hooks up into multiple different things in the back of the cabinet. We monitor the AC power. If the cabinet goes into flash, those are two critical things for connected vehicles, because what happens when your signal goes dark, what happens when your cabinet goes into flash with connected vehicles, you have to still be able to broadcast that message to the vehicles that a signal's dark and you should treat it as a 4-way stop. So there's a small battery in here that runs this unit for about 5 hours, so that even when there is a power failure event, you can notify the vehicles that there's a power failure event. But at the same time, you're also notifying your technicians that there's a power failure event, so that they can call the utility company. Or if it's a cabinet going into flash, you can alert the signal company, the signal techs, that there's a cabinet that's gone into flash and that they need to go down there to investigate it. And we tell you if it's in conflict flash as well. We also integrate to the conflict monitor to tell you if there are multiple red lamps that have failed. You'll see here that there's a 4-port Ethernet switch as well built into it, so you can hook into other devices within the cabinet, or you can just plug it directly into your network switch as well. There's high-speed cellular communication, radio, and GPS. There's 2 outlet sockets over here as well that also allow you to remotely cycle outlets at the signals, so that you can get your first, let's say you have a network switch that fails from time to time, or you've got cameras that you want to restart, you can restart everything remotely. There's a temperature sensor in here. So what it's doing is it's monitoring everything within your cabinet, and also getting that critical information back from the traffic signal controller. So basically you plug in an Ethernet port to the traffic signal controller and the conflict monitor, CCTV cameras, whatever you want to hook into it, and it gets all the information from NTCIP or specific connected vehicle protocols to tell you when the traffic signal is going to change. And it also provides remote communication to any single traffic signal. So this is primarily what goes into traffic signal cabinets, to get all the information back from the controller and then broadcast it to the TravelSafely app. And this is what goes into school zones, curve warnings. This also goes into the work zone devices, and this acts on a school zone as your timer switch, where you can remotely create the schedules for your school zones. You can do snow days and you know, control everything with your school zones and monitor the solar panel and the batteries and the lamps at your school zone so that you make it an internet connected device. And at the same time, it broadcasts the messages to the TravelSafely app so that it knows when it's in an active school zone or when it's in an active work zone or sharp curve or in a driver feedback sign area, so that it can get, you know, broadcast all that information to the TravelSafely app. For the technical guys, I thought I would go into this quite quickly, just to showcase the sort of the way that everything works. You've got a traffic signal controller, your Siemens, Nasdaq, Econolite, whoever you're using, and our device that you saw in the cabinet there is communicating to that controller, getting signal phasing and timing information and sending detector information, preempt and priority information to the traffic signal controller. And then we broadcast all that information over the cellular network to all the mobile apps. And at the same time, if, you know, we've got some cities that have DSRC radios installed as well, so that you can also get it in DSRC equipped cars. Obviously, there are not very many of those at the moment, but we have the ability of interfacing to all of the different manufacturers because we utilize the international standards, the SAE J2635 standard that basically creates these BSM and SPAT and MAP messages to send it all out to all of these different things. And you'll see over here, there's also other devices, because what's quite critical is a lot of people have talked about traffic signals for connected vehicles, but there's a lot of, you know, as you saw in the videos, there's a lot of other devices within your cities that are also really important to get connected to the network, like school zones, driver feedback signs, emergency vehicles. All of those different types of devices also need to be connected to, you know, to the whole connected vehicle platform to provide a, you know, a big safety impact for everybody. So Marietta, Georgia was one of the first cities to fully embrace this technology. They've deployed it at about 140 signals, 40 school zones, 40 driver feedbacks, about 40 emergency vehicles. They got in, you know, over 250 devices, and every single one of their signals connects to the TravelSafely app and broadcasts all of that information. And you know, it's quite amazing driving through the city, because every single one of their traffic signals now talks to you, and it's kind of, you get onto these roadways, and then you drive out of the city and you go, oh wow, you know, you kind of leaving, you know, a very technologically advanced city and then going into the next city, and obviously the city next door to it's now planning on putting it in. City of Atlanta has started their implementation. They've got it in about 50 odd signals, and they've got it in there on about 700 school zones. So there's a huge number of devices going out there. The University of Alabama is doing a big research project into connected vehicles. They deployed it on in every single signal in the city of Tuscaloosa, where they have 85 signals connected, and you know, they're doing, you know, all sorts of PhD projects in terms of, you know, what is the impact of providing a get ready for green message to the motorists in terms of startup time, because now they're seeing an impact that people are starting up quicker that are using the application, because over the last couple of years, there's been a significant deterioration in people pulling off at signals And the main reason for that is more and more people are using their smartphones at red lights, which is, it's just a fact. And what they're seeing is people are able to put down their phone and start up, because as much as we try to outlaw it and everything like that, people are still picking up their phones in the cars to check emails. But this is now giving them a 3-second warning, get ready for green. People put down their phone and they start driving. And the whole idea is this app runs 24/7 in the background and connects you to all the traffic systems and to emergency vehicles and pedestrians and cyclists to provide this lasting impact on the safety side. And we don't expect people to be running the TravelSafely app as a, you know, the main screen app, because people will always be using Waze or Google Maps or, you know, whatever they want to utilize there, and it'll all be audible alerts that'll come in the background. So the apps we're doing: SPAT, red light running, bus transit, the school zones, work zones that I didn't mention earlier, rear end collision. That was another one I didn't mention earlier, which is basically each app communicates to each other and detects if there's, you know, congested traffic ahead and there's stopped vehicles ahead of you and you're traveling too fast. It will actually come up and say brake, you know, giving you a warning that you're going to hit the car ahead of you. We're also doing a bunch of other things in terms of wrong way vehicle detection, DMS sign annunciation, weather warnings in terms of whether or not you know, there's icy roads ahead, congestion ahead at signals, railroad crossings. So when there's an active railroad crossing ahead, we actually broadcast out to the vehicles ahead of the time. You know, there's a couple of cities we have around here where they have some freight trains coming through, and you know, that can take 5 minutes for the freight train to go through the city. And if you can tell the motorists in their vehicles that there's actually a train crossing ahead, we can provide a warning when they have an option, you know, to turn left or turn right to take an alternate route, that there's an active railroad crossing ahead. And there's some emergency, some event management where we provide parking information as well, in terms of where to find parking within, you know, the different cities and that. Sorry, I jumped out of that. There's the other aspect behind this, and you know, a lot of people have been talking about this for quite some time, is, you know, detector information. How do you now get advanced detection information at every single one of your intersections and approaches without deploying new detector information, advanced detector information everywhere? And this is, you know, obviously the cars are going to start to have all of this technology built into them, and, you know, getting the smartphones out there allows you to actually get advanced detector information for every single approach. So what it does is, each time a vehicle is approaching with a smartphone on, it's sending it, just as it's getting its information from the traffic signal, it's sending information to the traffic signal that it's approaching, and we're able to interface to the traffic signal controller either via Ethernet or a detector card that puts in a detector call 10 seconds in advance, so that if someone's driving late at night and there's no one on the roadway, normally what ends up happening is they would drive up towards a traffic signal, go to, you know, if there's no advanced detection, get onto the stop bar, and then the stop bar would detect them, and then the traffic signal would take 10 seconds before it goes through its minimum clearance times and then provides that person with a green light. Now you're sending that information ahead of time, so there's no reason, if someone downloads the app, that they should ever have to you know, have that situation happen for them. And also it makes the traffic signals work better, because now all of a sudden you're getting a higher density of detector call information, more in advance so that you can utilize all these advanced functionalities in your traffic controllers to make it work better. And there's an incentive for Joe Public to download the app because traffic signals will work better for them. And they get ready for green. And at the same time, you're then able to layer on all of these other safety aspects for speeding in school zones, speeding in work zones, and all of those things that are providing this real safety for the citizens. So, that in a nutshell, kind of what we're doing with the connected vehicle side of it. Fayed, do I still have some time or do I need to stop? I was just going to explain some of the smart city functionality of the equipment as well. Just wanted to check if I've still got some time or if I need to stop there.
Peter, I think you're good. Just have a quick question, and I'll take this opportunity to put it out to anybody who has any questions. Please post your question in the chat bar so that I can see them, and I'll post them to Peter. Peter, the one I have right now is does the intersection hardware track Bluetooth or Wi-Fi detection?
No, we don't. We track obviously all the apps coming in so that we can get, in other words, utilize all that data in terms of doing origin destination of all the apps. We also obviously provide a remote communication available for other Bluetooth devices to basically track the vehicles if you're wanting to do that. So it'll have the cellular communication ability of connecting Bluetooth or whoever else you utilize for connecting, getting that information.
Okay, sounds good. Thanks, Peter. So once again, just a quick reminder to anybody else online right now, if you have any questions, please post them up. Peter, you can continue. I think if you can go for check back again in about 5 minutes.
Okay. So what we're doing is obviously providing, all of this connected vehicle technology, but at the same time, all of those devices connect back to the Glance central system and provide real monitoring functionality and control functionality for the city. So, on intersections, how do you know the difference between a communications failure, traffic controller failure, or power failure? And with the current central systems, there's no way to do that. What we have is an internal battery and a built-in cellular modem that actually tells you the difference between an AC failure, a controller failure, and a communications failure, because each of those have a different effect in the field. And we found, after deploying all of these devices, 90% of all failures at traffic signals are power failure events. 5% are cabinets going into flash, and the other 5% are other kind of failures. But having that battery in there really provides that ability of seeing where your AC problems are to send a utility out to get it fixed, or where you need to put in battery backups. We integrate to the conflict monitor to get cabinet flash. We integrate to the battery backup systems to get all the alarms for the battery backup so that you know exactly what's happening there. The conflict monitor, we've got a temperature sensor and humidity sensor built into the piece of hardware. And we monitor cabinet fans and heaters as well. You can do remote power cycling, and then controller pass-through that allows you to use your Tactics or Centrax or ATMS.now system to communicate directly to the traffic controllers that don't have any fiber or communication to it. We also build in remote front panel, so you can access the front panel display of any of the controllers within our user interface, so you can connect into a web browser and actually get access to that. And then on school zones, the question is, are your school zones actually working? And most people say, well, the only time I know that is if I drive through in the morning or in the afternoon when the beacons are on to see if they actually physically go on. So we actually monitor the current through each individual beacon, monitor the solar panel, the battery, to actually determine whether or not your school beacons are working correctly. And we obviously do the schedule control when the beacon turns on, turns off. We implement snow days so that you never ever have to go back to the beacon unless there's an issue with it. You never have to reprogram it. Everything's done from the central system. You can remotely override them. And then you can also hook up into the traffic calming speed feedback signs. As you saw in that video, we connect up to them and get all the information in terms of median speed, average, the 85th percentile, 95th percentile, and the volume of the vehicles on the roadway. Then the same, yes,
sorry.
Go ahead.
Yeah, we got a couple of questions.
All right, go for it.
First one is, whoa, I lost it. Hang on a second. Would the intersection tracking have the ability to compile traffic counts?
Yes. So
okay.
in terms of that, what we actually would do with the traffic counts is we actually can get that directly from the traffic controller itself. So we actually get all the high density data files from the traffic controller, and we can compile all of the the high density data files in terms of everything coming back from the traffic controller, and provide you with a dashboard in terms of how many vehicles are getting green lights, the count information, as well as obviously getting information from the app. But the whole idea is, the app isn't connected to every single vehicle approaching, so we get all of that directly from the traffic controllers themselves.
Awesome. Okay, the other question I have here is, are all signal controllers set up with both the DSRC radio and cellular modem?
The answer is no. So we've got a couple of places, like for instance, City of Atlanta. They've got 44 signals, and they're doing a pilot project there, and they've got 20 of those signals have got DSRC radios and cellular, but the rest of them just do cellular. The reason for that is it's a hell of a lot easier getting someone to download an app on a smartphone than it is to get someone to install a bespoke radio into their vehicle, install an antenna on top of their roof, and then connect the same smartphone Bluetooth connection to the radio and then run it. So we support both, but you don't have to have DSRC. And our view is, whether DSRC wins or doesn't win, the prices of those radios are going to drop down significantly. And what we've done is we've focused on the applications. So making all these applications, with get ready for green, when the traffic signal is going to change, and whether it's 5G, 4G, Wi-Fi, whatever communication technology it is, we're going to support it. So we support all of them, and we support almost all the DSRC radio manufacturers right now, and all of the traffic signal controller manufacturers right now. So the answer is the researchers are doing DSRC. The cities that are implementing it for safety for their citizens generally are staying away from the DSRC at the moment because they don't see any benefit to their citizens yet.
Perfect. We have one more question, and this is about the cost, because I guess in a scenario you may have 140 signals, and to fit all of them with the cost could be high. So can you talk something about that?
Yeah. So I mean, here in the rough cost of the city of Marietta deploying their system was about $500,000, and that's for them to have it for the next 5 years. So that's 5 years of communication, 5 years of maintenance, of upgrades, of extended warranty, everything like that. So that, and that was installing them as well, getting a contractor to actually install all of them. So when you look at the actual costs of all of that, actually isn't hugely high, and that provided them with emergency vehicle preemption as well for all of their emergency vehicles as well.
Okay, one more question. experiencing with talking apps is that it can be non-stop and users can just shut them down. Can you comment?
Absolutely. So we've got a lot of focus groups, and that's why we don't provide that many alerts. At the traffic signal, we provide the get ready for green, which once you've used it, that's the one that you're going, oh my goodness, I wish every single traffic signal talked to me like this. And then we only provide alerts if someone's driving really fast towards a traffic signal and we see that they're not going to run, that they're going to run it. They get the alert. On school zones, it only happens when the school zones are active and someone's driving more than 5 miles above the speed limit. Now, if someone's, and it provides it once when they go over the speed limit, if someone's going to be the type of person that says, you know what, stuff traffic, I'm going to go and drive at very fast speeds all the time, they generally don't want to download the app in any case. This is for the people that are wanting to provide active safety to themselves, because they don't want to hit a school child and kill one. They don't want to be hit by an emergency vehicle. So those are and when you drive around in the cities, it doesn't feel like you inundated with alerts. The same thing with the cyclists and the pedestrians. We only provide alerts when we detect an impact and that the car is driving more than 20 miles an hour, more than basically 30 kilometers an hour faster than the cyclist, because those are the accidents that are going to kill people. And we don't want to have too many alerts. So we're very, very cognizant of providing too many audible alerts versus also, providing enough that we provide that layer of safety.
Perfect. Thanks, Peter. And we have questions coming in, and just to give you guys a heads up, we had asked Peter to stick around for a few more minutes after. So if you guys have time, by all means, please stick around. We have a couple of questions, Peter, right now. So one of them is, how many signals does Marietta have?
They've got 120 traffic signals, and then I think they've got about 10 hawks as well. So it's about 130 traffic signals, 40 school zones, 40 driver feedback signs, about 25 emergency vehicles, and then they've got some dynamic message signs and some snow plows and things like that.
Awesome. The other question is, how about actuated signals? How is the time provided when approaching from a distance, and the timing phase may still change? Is there a prediction?
So there's always that case on vehicle actuated signals. If you're running a vehicle actuated signal and you're getting the information back from a Siemens controller or an Econolite controller, you will see, if I go to that video, let me see if I can go to the Richmond one. Now these were fixed time controllers over here. And
get ready for green.
If you have a look at the app, you'll see basically as you approach, you'll see a countdown. Now, when the countdown is 5 seconds, well, it never jumps then or within about 7 seconds, because you're going through all your minimum clearance. So there are never any jumps there. If it's showing 30 plus seconds, you will sometimes see when a vehicle actuated intersection, you'll see the spat jump from 30 plus seconds to 15 plus seconds. That does happen because obviously the timing on a vehicle actuated signal is changing. Now, on our viewpoint, most people are not going to be utilizing this display over here. They're going to be running Waze, Google Maps, and they're going to be getting the get ready for green audible alerts, which will always work with any type of traffic controller. So in downtown Atlanta, we actually have some adaptive controllers, and obviously they're adapting second by second. but we always have 7+ seconds that we know before when the traffic signal is going to change. So in those situations, you would just see it saying 5+ seconds, and that could be, you know that you're going to wait for more than 5 seconds before the traffic signal is going to change. So vehicle actuated signals do their spat timing would jump, but for our application purposes with the audible alerts and things like that, it doesn't really affect us hugely.
Okay, one more question, Peter. Does Marietta have actuated signals?
Yes, majority of them are actuated signals in Marietta. So you actually see it. Now, some of the controllers do a better job in doing the prediction on actuated signals. You'll see that basically their predictions are becoming better and better in terms of predicting the timings, but that's just how an actuated signal works. It will be running, sometimes you'll get it sort of extending a green or whatever is happening in the traffic signal, and your timings will definitely change depending on how the actuated signal is programmed.
Perfect. All right, sounds good, Peter. I don't have any further questions. I know we're about 4 minutes over the scheduled time. I guess one of the questions is, do you have a local business connection here?
Yes.
In Ontario?
We are working with innovative traffic solutions or innovative transportation solutions in Ontario, who distribute our product, install it, help maintain it. So we have a local company that's providing all the support to us in Canada, and we've actually got an office in New York, in Albany. So we actually have a local office there that would probably end up being doing the support for the Canadian office or Canadian people there as well.
We are working closely with Peter, and when it comes to the Windsor-Ottawa corridor, our intention is always to bring forward technologies that that really do something very much better than what's out there today, what you normally see. And we hope that today's webinar kind of showed you the good things that Peter and his team are doing. Peter, thank you once again, and we hope you come back again and share some new stuff afterwards.
Yeah, absolutely. Really appreciate everybody's time, and thank you so much for listening to me. You can obviously hear how passionate I am about this technology, because I really see it as a real life-saving technology, and it's something that can be implemented today, which instead of waiting for people to legislate things, this is something that we can put out on the roadways today and really start providing real safety and start trying to save lives. So that's what we're all about in applied information, and that's why the app is free. It's a free app for the citizens, because we can get far more people on.
Peter, can you just put on your contact information?
Sure. Did I not actually put on my contact information on my, wow, on the presentation? I should have the contact me at the end of it.
No, I don't think we let you go until the end, so we stopped you before.
No, all good. So this is my contact information over here. So my telephone number is over here, 678-276-6952, and my email is pashley@appinfoinc.com. And you can see everything on our website, www.appinfoinc.com. And the other one to go to is the TravelSafelyApp.com. And
Perfect.
that's
Thanks.
video
Yep.
and everything like that.
Excellent. Thanks again, Peter. And one last thing is that we are working with Peter for some good opportunities. So if you're interested in deploying the service in your local city, please contact me, and then we can continue discussions. Thanks again, everybody, for joining. Thanks, Peter. Talk to you soon.
Thank you very much, everyone. Bye-bye.